Started recording. Yeah. All right. Um. So Secret and Bisect. Okay, Nikhil, you wanna?
Yes, screen is not
Sorry.
Screen is not
screen
visible.
is not visible.
Oh, is it so? Haven't I shared it? Give me. Yeah. Tell me if my screen is coming up.
Yes, now it's
Great. Sorry for the thing. Or else I can show it to you here also. Go ahead. You want to look at this or take the paint?
paint will be visible.
All right. Mm-hmm. So we have S here, right? So that means how do you find the distance here? Okay. So I think if you want to convert secret, or let's say like if you want to convert bisect to secret, right? Modify. Am I right, Nikhil?
Yes, yes,
If you want to modify bisect to secret, so I think we need to delete B, right? So one delete operation, we have to delete I to or second delete operation, and we have SEC, right? After this, we need to insert RE, one insert which is R, I mean which is an insert, and E which is another insert, and T is already there. So if we do like that, SEC RET, so this is what edit distance is. Am I right?
yes.
Uh, should we talk about something else? I mean, take a different example. Add and subtract. How to find edit distance for these two? Any idea? I'm taking these two. Let's find out what is the edit distance. And it says that it is 7. Okay. And how do we do that? So basically, either we convert uh, this the first word to the second word, or second word to the first word. It doesn't matter, right? So let's say that we are converting add to subtract. Okay, earlier we were converting the bottom one to the upper one, right? So now the top one will be converted to the bottom. So do we have an A here? Yes, right? So we have an A. That means we need to insert these many things in front, right? So 5 insertions are required, right? 5 insertions. Then we have A here, and C should be replaced with D. I'm sorry. D should be replaced with C, which means are you guys following little bit? Uma, are you able to little bit understand?
Yeah, I'm getting it.
A, and then instead of C, we are going to make it as, you know, we are converting add to subtract. Huh? That's what we are trying to do. Okay, ADD. So we have A here, and so I'm gonna insert so many things. S U B T R A, and instead of D, we are replacing D with C, another D with T. So how many operations has gone? 1, 2, 3, 4, 5, 6, 7. 7 operations are required. Pooja, this is week 9 content. Next session will be revision session for quiz 2. Uh, is this okay, Uma? Little bit.
Yeah, got it.
All right. So now we look at the code on how to do this. All right. Can someone help me here, guys? Just to go through the code to travel along with me. Mahi, can I take your help?
Sir, I just joined. I don't know
Yeah,
what is
just
happening.
all that I want from your side is you know, right? All that I want from your side is just read the code. All right. So what is third line saying?
It's M comma N.
which is
Then of
for add and subtract. Can you tell me what is M? M is 3, right? Mahi, are you following? M is nothing but the length of U. U is the first word that you are passing inside, right?
sir, will you please explain what is happening here? I just joined.
Right. So we are trying to find out the edit distance. Okay. What is an edit distance is basically you're given two different words. Okay. One is there, two is here. Okay. So if you want to convert one to two, so you are given ONE. All right. So they are asking you, I want the letter TWO. How do you convert one to two? It's like you can do three different types of operations. One is insert. Okay. Uh, INSERT. Second is delete. All right. And third is substitute. Are you getting something, Mahi?
Yes, sir.
Right. So in order to get one and one to convert it to two, so what you can do, this one you can, I mean, this O is here, right? So probably we can match it here. Okay. So O and E, and we have TWO. Since these two are matching, all right. So now we are converting one to two. Um, you need to do how? Okay, let me just check it. Even I'm not sure how many distance you need to do. O N E T W O. Right. So the edit distance is 3, which
I
means,
thought it's two, right?
yeah, go ahead.
No,
Uma,
I
it is
thought it
3
is
only.
two.
Yeah, it is
How is
3.
three?
Uma,
Supposed
tell
to
me,
be two. Yeah, it is supposed to be two, no? How it is three?
how do you say it is 3? I mean, how do
No,
you say
I'm
it is
telling
2?
we're converting one to two, right?
Correct.
O is already there.
Yes. Okay. So if you're saying like that, O is already here. Okay. But you have NE on the
Also,
right hand side. You're supposed to insert two things on the left and delete two things on the right.
yeah,
Right. So two insertions and two deletions. This will give us as four operations.
yeah,
Right. So this is not the, I mean, instead what you can do is, instead you're going about the efficiency. All right. Okay. Instead what you can do is simply you can substitute these things, right? You can substitute O with T, right? N with W and E with O. Got the point? Now we are doing it in three
yeah, yeah.
operations. So this is more
Okay.
efficient than doing that, even though you have a common word.
Yeah,
Right.
I thought I was including the common. Okay.
All right. So this is how, Mahi, are you able to understand a little bit?
Yes, sir.
All right. Good. Mm. So now coming to the code, that is what we are trying to find out here. This code is going to given calculate us what is the edit distance. Got it?
Yes.
How to find out the edit distance. And M, and can you tell me what is N here?
N is 3.
Very good. All right. So ED equal to NP dot zeros of, again. So we are gonna create a table, right? That's a matrix. It's creating a matrix, right? Hello.
Yes, sir.
All right.
Zeros matrix.
Okay. So what is happening here?
We are iterating varied range combination.
Mm-hmm.
It's thing.
And I'll try to print this. All right. Print PD. Let's see what is happening. Yeah. Okay. So for the last row, you're putting 0, 1, 2, 3. I mean, so this last thing is going to be 0. Everything like it's completely 0, and 1, 2, 3 you're putting here. So that's the first thing, and let's see what is happening. The next one, ed. Ha. Okay, 1, 2, 3, 1, 2, 3. They are filling it like this. I think this is what the basic thing is we are supposed to do. If we come here also, if you want to find out the edit distance, see, you remember yesterday we were putting 0 0 0s everywhere, right?
Yes.
Right. So now for edit distance, we are supposed to fill it like this: 0 1 2 3 4 5 6, whatever, that to the towards the length. Okay.
Yes.
So that is what has happened in the code also. Fine. Now we'll go forward. All right. So this is basically iterating, and it starts from n minus 1, which means 2, right? 2, uh, 1.
10.
Yeah, and it stops at 0. Great. And the next iteration, in this case,
Same.
it's same, right? 2 comma 1 comma 0. Good. All right. So what is it saying? If u of I equal to v of j, all right? So u is the first one and v is the second one, right?
Yes.
I mean the first word and the second word. Basically we are iterating I.
And we are checking if one is equal or not.
I think we are checking whether so for the last word we are checking the I mean second word we are checking the last character is any of these three.
Okay.
Am I right? That is what is happening. See, um,
Go to like every other word of the second one.
correct.
O2.
Repeat.
We are checking O2 every word of two.
That's correct. Every character of ONE. See, I'll show you. See, let's say like j equal to 2, and this is gonna run for 2 1 0, right?
Yes.
The inner loop. And what is u? U is the first word, right? So if you see, u is the first word. So that means what is first word?
O.
When me, right? And basically, first word of I. What is I? During the for first time, I equal to 2 1, and then we have 0, right? So for the first iteration, uh, we are checking v of 2. U of 2. What is u of 2? It is e, right? Equal to 0. This is the first iteration. Then n equal to, it's not 0, I mean o. Are you following?
Yes, sir.
Right. So during the next iteration, what we are doing, o equal to o, right? During the third iteration, we get it, there is a match. Am I right?
Yes.
At what time? So when the left hand side, this o equal to 0 is nothing but 2 comma 0, right? So when sorry, it's 0 comma 2, because I will be 0 and j will be 2. Are you able to follow this? What I'm doing?
Yeah, yeah,
Mahi?
Yes, sir.
Okay. So in this case, what are we doing here? Ed of I comma j. All right. So 0 comma 2 will become ed of whatever we have it at the bottom. Let's go here and once see this code. Okay. So coming here. So we are checking edit distance for bisect and secret. Okay. And what's happening here? We would have here. Okay. So if a of I equal to if they are equal, so if t and t are same, so whatever is on the lower diagonal, you put it here, right? If the, I mean, if it is t, I mean, if they are same, whatever is on the lower diagonal, you are supposed to put. If it is not same, minimum of the diagonal, the left one and the right one. Okay. Uh, who is able to follow and who is not able to follow? Can someone tell me about that, guys? Hello. Hey, please. Can someone tell if you are able to follow or not? At least.
Yes, following.
Okay. Who is not able to follow? I know I'm not telling it in a very efficient way. So there should be some people. At least tell now.
So Pooja is not able to follow.
Who? Ravina.
Pooja.
Why do you say other people's name?
So she wrote it.
Acha, okay. But you understood, right?
Yeah.
Okay. We are talking about grid distance. Sorry, suddenly my laptop has become slow because of too many processes going around. Just give me a second. I'll just take the picture. So you'll be able to write it. Um, I don't think I have it here. But do we have a box? Like how we started here? I don't think we have. Okay, yeah. Thank God. Um, Okay, here we are. Mahi, you remember what was the first step to do?
1, 2, 3, 4, 5,
Good.
6.
4, 5, 6. Right. 1, 2, 3, 4, 5, 6. This is the first step. All right. So after doing this, and I'll take you the inductive structure. Okay. Here we have the inductive structure. All right. So tell me, Mahi. So here we have T, and here also we have T. So that means we are at this point. So on T and T matches, right?
0.
No, look at what is happening. Yeah, zero. Why zero? We should put
Because of the diagonal limit.
whatever is on the diagonal. I mean, the rightmost diagonal, right?
Yeah.
Okay. So we are putting this value. So if we come here to this point, all right. So it is C and T, which is not matching, right? So we are going to this if condition, all right. So at this point, what are you supposed to do? Minimum of what is this? So we are at this point, right? So this is I comma j, right? Star is representing I comma j. Okay. So can you tell me which box is I plus 1 comma j plus 1? I plus 1 is, let's say, here, and j plus 1 is this. So diagonal, right? 1 plus minimum of lower diagonal, comma. So can you tell me now what is this? I plus j means I plus 1 comma j.
0.
So the bottom one, right? Bottom, all right. So if this is nothing but the right,
2.
whatever value you have on the right. So you should take the minimum of the three. So what is the minimum of the three?
0.
0, right? And add 1 to it.
1.
So we are supposed to fill 1, all right? So we are filling 1 in that. Okay. So for this point, is E and T same? No, right?
No.
No. So we
So
are
it
supposed to.
becomes two.
Very good. Next.
It is 3,
Good.
4,
hmm
5.
5. So can someone else take this now? Pooja, did you understand a little bit? Are you able to talk? Ravina, Uma, anyone?
Such one.
Yeah, Ravina. Okay. So this is supposed to be 1. All right. Fill this line.
1.
Good.
Same 1.
Hmm. Whatever is on the diagonal, right? Yeah. Then
Not same 2.
good.
Not same 3.
Mm-hmm.
Not same
4.
3 plus 4.
All right. Good. So Uma, would you like to take it?
Yeah, yeah. Next one is we are comparing with T, right?
T and R.
T and R.
Hmm.
Okay, yeah, one
Huh?
and two
Good.
and four.
Basically, we don't have any R here, right?
Yeah.
So we can
So
directly
it's
go on. Here, what
we are
am
going
here? What am I supposed to
two,
put? 2. Good.
two,
Here.
and stroke two,
Good.
and yeah, two,
2 again. Nice.
three,
Mm-hmm.
and four.
Good. Okay. So Uma, you want to fill the next one also?
Yeah, okay.
Mm-hmm.
We are comparing T with
C.
yeah, three,
Right.
three, three.
Why 3?
Okay, sorry, two, two. It's same, no? C, C. Yeah,
C
two,
and C are same, right? So we need to take whatever is
two.
on the diagonal. Good. 2.
And this E, yeah, three.
Good.
This is three,
All right.
and this is also three.
Good.
It is also three.
What?
Two.
It's 4,
Okay,
right?
okay, yeah, yeah. Sorry.
Got it, no? Anyone else want to do
Yeah,
it? Subramanyam or Vikram? Subramanyam, you want to take this? All right.
I can give it a try, but
Yeah, give a try now. That's all. Everyone is actually trying here. Even I'm just trying here. Right. Don't worry.
uh, T and E not matching. So it is
Is it visible for you, or you want me to zoom it better? Zoom a little bit.
no, no. It's okay. It's okay.
All right.
Yeah, not same. It's
It's
three.
T. So T and E is not same. So we take the minimum plus 1.
Yeah,
So it's 4,
minimum
right?
is four.
The minimum is 3. So 3 plus 1 is 4.
Yeah, C and E is not same, and minimum
Correct.
is one. So two plus one, three.
Good. E and E are same. If they are
Yeah.
same,
So D two.
choose the diagonal element. Good.
Yeah, I will. And S and E not same. Three plus one, four. Four.
No, wait. S and E are not same. So we take the
Yeah,
minimum plus 1.
or two plus one, three.
Very good.
And yeah, three plus one, four.
Good.
And
And
the
E.
4 plus 1, 5.
No, minimum, na? Minimum of the 3. Minimum of
Minimum,
4, 3, and 4. Got it?
yeah, 3.
Yeah, minimum is 3, and the answer we are supposed to write is 4. 3 plus 1.
The minimum of 3. So it should be 3, 4, 3, 4.
Correct? 4, 3, 4. And the minimum value is 3, right?
Right.
And
So 3 plus,
3 plus 1.
okay, right. Thank you.
Yeah. So I want you to fill the next column also, one last column. I don't want to ask someone else to do it. Can you fill up the next one also, please?
Yes, T and S are not same.
Mm-hmm.
So minimum of 3, 0 plus 1, 1.
Sorry? Minimum of? How come 1 here?
Minimum, minimum of that no, 0 plus 0, no?
This is 6 actually.
No, 6, 5, 4.
Huh.
So 4 plus 1, 5.
Good. C and S doesn't match.
doesn't match, and 3 plus no 1 plus 1 2.
Huh?
No, here 3 4 5.
Correct.
3 plus 1 4,
Mm-hmm. Go ahead.
and it is 2 plus 1 3,
Yep. Very good.
and
It's matching.
matching. Yeah,
If it is matching, we should take
yeah, matching this T 2
good.
diagonal.
Hmm.
Not matching, so 3 plus 1 4.
No, if it is not matching, should take
Oh,
the
2 plus
minimum.
2,
Ah,
2 plus 1 3 3.
good.
Then also not matching, so
Yeah.
3 plus 1 4 4.
Four. Right. So what was the edit distance for bisect and secret? BISECT and SECRET, right? Just like how we saw earlier, right? So SEC is matching, and T here is matching, right? So and let's say like I'm just converting bisect to secret. So that means I'm deleting two deletes, right? And here I need to insert two things, right? 2 plus 2. So four things we are supposed to, four operations are required to convert bisect to secret. Am I right? So that
Yeah.
is what we got four here, right? Answer.
Right.
So let's also confirm whether our answer is correct because even I just tried out. Um, just copying this, right? Let's have it here. So do we have the same on the both left and right? 4 4 4 5 6. Yes. 3 4 triple 3 4 5. 2 3 3 2 2 3 4. Yeah. So this is perfect. Like whatever we have got, we have it on the right hand side also. Like this is how we are supposed to form it. All right. Then how do we find it out?
So I have it down.
Yeah.
So we can just replace RE by BI, so it will take only two steps. Wow.
SECRET, BISECT. Okay. So tell me, what do you want to do? Replace RE with.
Yeah, I did it wrong. Okay, so
Hmm,
got it.
yeah. So how do we traverse back, like, you know? So so see, you start from zero, right? So wherever I mean, uh, one 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 two two two. How do I say this actually? Hmm. Okay. So I believe we start from the this part. All right. So we traverse in the uh, path where it decreases. All right. So from 4 it is 3. We come here. Okay. We come here. So these two places it's increasing. So from here you traverse right. You travel right again. All right. So if you can see, we are at this point, right? So as I told you, the stream goes in the lower way, right? If it is decreasing, go in that way. Okay. Here also it's decreasing again. So at this point it's increasing, so we are not supposed to go there, we are supposed to come here. All right.
No, sir, but how 2 is decreasing and it's going to the next 2 only at the 5 comma.
Either decreasing or equal, you can say like that.
So, sir, if it is equal, so it can directly go to right side also, no? While
Where?
it's going downward.
At which line? See,
At the 4 and
the
it's
first
not.
condition the first condition is, see if it is decreasing. If there is no decreasing, go into an equal side. Okay, Ravina.
Sir, my doubt is
Hmm?
like we went in the diagonal way from 2 to 2,
Hmm?
but at the right side also it's 2 to 2. So
Uh,
why we don't take that
2 to
path?
2, right? I think this is what you're saying, right?
No, sir, down, down, down. At 5 comma 1, like 5 comma R.
Okay.
This one and the other one.
This part.
This part. So why we didn't went towards its right? Like it's not decreasing there also, and it's not decreasing downward also. So why we take only this path?
That's right.
From CC, what she is asking CC.
No,
No,
I'm
that's what.
asking this selected.
So CC, right? From CC,
Yeah,
how it is? Why
because
do we go here?
yeah, then decreasing is there. So why are we not going there? That's
Mm,
what she's asking.
that's right. Can anyone answer this?
No, still you can go there and go at one and get
So,
down.
what you're saying is we can still go here, right?
Yeah,
And
yeah,
then again we can go here also.
yeah,
Right? It's one either down or right. So
yeah,
now we have a zero here, so we go
yeah,
down, and we have a zero down here, right?
yeah, yeah.
So what does this mean? What does this diagram mean? Can you tell me?
Same.
What does same means?
Okay, I
Weights in the boxes are same.
Okay. Yeah, Uma, you wanna say something?
yeah, I thought it was down to up, right? I'm guessing, I'm not sure. Because when the diagonals are equal, we are going, otherwise we are going towards the left.
Uh, I'm see even I'm not sure about this. I just want some of you guys to give a comment on this.
That's what, from down to up we should go. Only then we will reach the answer, right?
Okay.
Why did you start from top to bottom? Then we can't reach anywhere. Only from bottom to up we will have the answer, right?
Okay. So what you're saying is that what are we supposed to do?
Start from there. If the diagonals are same,
Okay.
it's my guessing, it might be wrong also.
Mhm.
We are going to the diagonal. If it is not, the diagonals are not equal, we are going towards left.
Okay. Even I'm not sure though. It's been some time. Let's see if we have
But we
anything.
calculated depending on the diagonals, right? So that matters, I think.
Reading of the solution. Transform bisect to secret. Right. Delete B. Mm, delete B. I think they are coming here from here only. Huh? Are they? Are they? But
So from, if you come from 4, what are we reaching actually and what are we finding out?
okay. I think they
See,
already have this right.
start
B.
at bottom right and fill the row. But if you're coming from top, what is the point in reaching to 0? What?
This is going to give us like, okay, what is the point in reaching zero? Is that what your question is?
Yeah, we want the answer, right?
So, so Uma, this table is giving us that you need to do two operations, right? We don't know what
Okay.
operation to at that do at what time, right?
Okay.
So probably
So
that
for
is what
that, we are coming from top. Okay, because I'm
I
not
think so.
getting that.
Yeah. See, so when if you're coming from bottom to, I mean top to bottom, see it's deleting. B is getting
Okay.
deleted. I is getting deleted. All right.
Okay.
See now at this point, see. So from here to here you're going right. So at this point you're see for 4 you're deleting it and 3 you're deleting it. If it is a I mean if it is a horizontal line you're supposed to insert I think. See they are
Okay.
inserting or so exactly that's what is happening. See if it is a diagonal line don't do any change. If it is a horizontal line you're supposed to delete I mean sorry vertical line you're supposed to delete and if it is a horizontal line you're supposed to insert.
Yeah, but we need the final answer, no? 4 operations. I thought we are reaching that.
And that we got it here right.
Okay, that
The value
value.
4 whatever you're getting at the top probably if you look at the code whatever it is returning we'll be able to understand that right. Ma?
Is it vertical line is delete, horizontal line is insert?
You're right vertical line is delete and horizontal line is insert.
What is diagonal line?
Don't no
See,
changes. No
No
changes.
So
change.
like there can be many paths now. Why we drawn it this way? There can be many paths.
This is the way like to get an efficient solution.
This is how you draw this line only. I'm just confused. Then only you are if you are getting this vertical and horizontal in the delete and insert operation. But for that we need to create this line now. So
Huh,
from your
just like how Uma told, right? You can take like that also.
what you told, Mama.
I told you start from the bottom. If it is diagonal, go up, reach the diagonal. Otherwise, move towards left. I told.
If the diagonals are equal, right? That's what you're saying,
Yeah,
Uma.
yeah, yeah, yeah.
So if this diagonal and this
Okay.
diagonal are equal, go up. Else you go towards the left. If you find a equal thing, go up, go up, go up.
If
Right?
you start from the bottom, you
Mhm.
convert secret to bisect, and if you start from the top, you convert bisect to secret.
Yeah, that is also correct.
Yeah.
Can we connect the mapping to the words bisect
Yes,
and secret?
yes. So, for
Where we
example,
are deleting and inserting?
yes.
Like
So
first, where are we reading from top to bottom or bottom to top?
both
Both.
the line works for both the words. If you
Can you
start
see?
from
Can
the
you see the
bottom,
words side by side?
yes. So if you start from the bottom right, which we have already done,
So
right?
two
So
two
let's,
deletions. We need a two deletion from bisect to secret. Is it? First,
sorry, I didn't get your question.
am I right in my understanding?
This line represents two things: converting secret to bisect or bisect to secret. So while populating the numbers, you started from the bottom right. Okay, you have already populated this matrix. Now just focus
No,
on the
Vi-
0. Please let me complete.
Vikram, can you hold on a minute? Let him write the words also on the side.
Vikram, from bottom to top means it's like bisect, right? We are converting bisect to secret, huh?
Yeah.
No, secret to bisect.
Okay.
Oh,
So, uh, so if you start now, let's start from 0 0.
Yep.
Okay, now you start from 0 0. You
Zero
know
zero
that
means here. Are you talking about this?
no, this
Like,
ij 0.
huh.
We already populated that from the bottom to up, right?
Mm-hmm.
So now let's understand how bisect becomes secret.
Mm-hmm.
bisect
Correct?
becomes secret.
Bisect becomes secret, huh?
Yeah. So now
That's what
we
I was.
start from 0 0. You can see top row 0, and
Oh, you're talking
so
about here. Okay.
yes, ij, right?
Hmm.
So vertical line
One second,
is
one second. Vikram, please, one second. Anwar, we are here at this point.
Okay.
yes.
Go
So
ahead.
now
Hmm.
vertical line will delete and horizontal line will insert. So
Right.
now we have a vertical line, okay, 4 3. So we delete B and I, correct?
Yes.
Right?
No, no, hold on a minute. What corresponds to deletion of B? Is it 423?
The vertical line.
Vertical
No,
line.
4. Yeah, the vertical line 423 is one, and 322 is the second one. Is that right? That's how to read it. Is it?
Forget the numbers now.
No,
Numbers
no,
you already, by moving from bottom to up, you have already populated the numbers, right? And
no.
you
Why I am asking this question because you are moving three boxes but deleting two letters.
Exactly. You should delete the this box.
right,
In starting.
because you moved vertically from there to 3, right? That's why you deleted 4, because you are coming from B. Now from 3 you go to 2. That's why you delete I,
Mm-hmm.
correct? Now starting from S, the vertical line becomes a slope, like a diagonal. So you do nothing. So S to E you move, you do nothing. So you keep S. E to C you move, you do nothing. So you keep C.
Mm.
Right? Then when you move to T, then again your operation changes. It becomes insert. And when your operation changes, it corresponds to R. So you insert R and you insert E, bisect becomes secret.
Okay. Okay. How do you go from bottom up?
Right. So secret we are converting to bisect. Am I right, Vikram?
Correct.
Okay. Anwar, you only tell, na? How do you go from bottom up?
Now going
No?
from bottom to up, same thing. You can figure it out.
We don't need to do anything for, see, we have a this slanting line. So we don't need to do anything for the T. Right?
Mm-hmm.
All right. So we
Right.
have two lines of what is this? Horizontal. Right. That means two insertions are required here. Am I right?
Right.
Is it two insertions or two deletions?
Two ins. The result in two insertions.
I
Right?
think If we are going in this way, we are supposed to delete these two, right? I mean, from secret, then only we'll have by at the top.
So the convention changes when we go from bottom up, is it?
Correct.
Horizontal deletion, vertical addition, huh?
Yeah. Vikram, do you see this?
Yes, yes, correct. So now, as you're going from the other way around,
Mm-hmm.
your horizontal becomes the deletion, vertical becomes the insert.
Mm-hmm.
Move to T, and then you move horizontally two blocks, which means the two blocks corresponds to E and R. So
Yeah.
you delete E and R,
Right.
right? And then you do nothing for C and E, I guess. Yeah.
Mm-hmm. C,
So,
E, and S.
yeah. Till then you do nothing, right?
You have three
Now
boxes. Right?
this horizontal vertical, which was earlier deletion, has now become insert. So
Mm-hmm.
once it jumps from 20 to 10, which is when it comes to I.
Yeah.
So you have to see when it goes up, it corresponds to I. So you insert I and then you insert B.
Hmm. That's right. Are we going somewhere forward? Oh, Subramaniam. Sorry, I think I misspelled your name. Sorry.
Hope everybody understood.
Yeah,
Yeah, but given a chance, I will come from top down. That's more easier than going bottom up.
Otherwise, it's the same thing, but just the understanding is there, right?
Yeah, yeah, that's right.
The
At the
three
end, in
things,
order to convert secret to bisect or bisect to secret, it's going to take the same length or same number of operations. It's always going to be the same, right? So,
yes.
yeah, you interchange and give, it's going to be the same.
And this is the least number of moves that we make to change it. Now,
Yeah.
Ravina was saying that there is some other way we can do it. We might be able to do it, but I'm wondering how. But it will take more operations.
Hmm.
But what Ravina was asking about an alternative path, no? Does it produces the result or not?
no, no. She's asking how did you choose that line starting point? I think.
Yeah. So which I
No.
made a mistake, Subramaniam, which I made a mistake. So now Uma corrected me saying that. So we'll start with the diagonals, right?
Okay, the rules are changing now. Just whenever the diagonals are same, just keep going.
Mm-hmm.
So not the other way around what we are originally
Correct.
talking.
So shall we try this for the same for different matrix?
Let's do this. Let's take a four-letter word and make a new matrix.
Exactly.
So it is much
You don't
easier.
need to do all the matrices. So we'll make
Right.
use of some this thing, right? Make use of the code. What do you say?
So take pray, P-R-A-Y.
PRAY. This is fine, I think, right?
Yeah, at least something should be common, right?
No, we have our common.
R, yeah, right.
Let's see. Not necessarily common, but it's okay. But let's see what we have. Okay, I think we should get the at the end. See, Uma, are you able to see? They are returning 0, comma 0, which means
Yeah,
the topmost. Got
yeah,
it?
yeah, yeah.
That clears. When
That was her question. Ravina's question was that how you start from there. So that is in the code. No, we are returning that point.
correct.
Yeah.
That shows us that is how we are doing it, right? Mhm.
Here there is no common. No,
Sorry.
here there is no common. I think there is no diagonal, right? See,
Let's see. Let's
same.
see. Let's see how it is going. Huh? So the diagonals are not matching, right? So we go left.
Because I think they are completely inserting or deleting the four elements. That should be the count four.
No, let's see. We have
No, R is common. No?
something is happening in between. Uma, see here. So the diagonals are not same. So we go towards the left. Am I right?
Yeah.
Okay, here again diagonals are not correct. So we go like this. So now we have diagonals are same. We go up, right?
Okay.
Diagonals are not same. We go to the left, right?
So the answer
Then we
is
go
wrong.
up. I don't know. So I think it was um FO. Okay, it's not that. FOUR, right?
Yeah.
And TRAY. AY.
First one was right.
Sorry.
First one was right. F should start from the start.
Sure. Okay. You're right. You're right. Four. AY. This last one is the extra additional thing, right? The dot one. Yeah. Go ahead, guys. So, Subramanyam and Vikram, can we do the same thing like how we were doing last time?
Yes.
So let's convert four.
4. So we are moving vertically down, I guess.
Yeah.
So we delete F,
Right. So we have like one, two, and three
3
steps
delete
down.
operations.
Right. So which means one, two, and three deletions.
Correct. And then we move insert,
Uh,
is it?
so yeah,
No,
that's
I
it.
don't think that's happening.
Still, yeah, I don't think so.
It's actually replacing every word. 4 3, you have to come back diagonally 4 3 2 1. Replacing every word. So F with T, O with R, U with A, and R with Y.
So here is an insertion, so which is T.
All four are substitutions.
All four are substitutions.
Yeah,
Okay.
that's what
Yeah, I
I'm
mean
getting.
that's the easiest way. You're right. I mean, all four, if we do all four substitution, that's giving us the lower.
The code is also saying that because if below 4 there was 3, then there would be deletion.
Okay.
But because uh, below 4 there is 4, so we have to go diagonally below. And here 4 we go diagonally to 3. Here also below 3 it is 3. So we are
So
not going back to
I'm
3.
not able to follow. Can you tell me again?
I'm saying uh, in the last slide, just a second.
You want me to take the slide? Okay.
No, no, no. No, no. Hello.
Okay. Yeah. Yeah.
If
Tell me.
if 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 the vertical numbers are decreasing, then only we are going downside. If there is a 4 below 4, we don't go below, we go diagonally.
Okay. Four below four. Then we go
Then we
diagonally.
go diagonally to 3. Then again there is 3 below 3, so we go diagonally to 2.
Okay.
Then again 2 is below 2, we go diagonally to 1.
Okay.
And diagonals are substitutions, I guess.
Diagonals are substitutions.
No, no,
No, no, no.
no.
Diagonals are
This
not
is incorrect.
substitutions, but uh,
Um. Why don't
that's
we
what I am
Why
thinking.
don't we watch just this part of the lecture? What do you guys suggest?
No, I mean it's quite easy, I guess,
Okay.
because we go whenever we draw this inclined line, which is a diagonal,
Correct.
it connects same numbers.
That's right. It connects the
And
same numbers.
yes,
But
and whenever you
if it's the same, then it connects same numbers. No? If 2 is be in the diagonal, then it is same.
Yeah.
Here we are decreasing diagonally.
See, look at this. If we, Nikhil, are able to see this?
Yeah,
See,
yes.
when we have the same
In the
diagonal.
diagonal, we are all 2s.
That's right. When we
We
have
are
the
not
same.
decreasing diagonally.
That's
but
right.
We are decreasing diagonally.
see, while taking the example, we are converting now tray to 4. But while writing, I guess we wrote 4 to tray.
Okay.
Anyway, it will work.
Yeah. So if you want to convert 4 to tray, then we have to start from the bottom, right?
Okay.
Anyway, it will work.
Okay. Four to three means you start from the bottom. I mean, that's something that's the part which I need to again reiterate. So, all right. So if you want to convert from four to tray, right, you are saying that we should start from the bottom,
Yes.
right? So, but still, we are looking at like seven different operations, right?
Uh, no, we
No.
keep the R, right? Now, if you want to convert 4 to tray, we keep the R
Okay.
and
We keep the
second,
R. What do you mean?
and we delete FOU, insert T, two operations, and AY, four operations.
T and AY at the bot after that. No, Vikram. I think we are confusing here, right?
then we need to draw the line again, I guess.
Okay, you say so. Um, go ahead. Come on, let me connect from the bottom. Shall I? How am I supposed to connect this? As you told.
Can you please write the uh, words? I mean, the word on the side.
What I should write here?
Tray and four.
Mm-hmm.
Right. So we are starting from the bottom.
Right.
Now we are comparing R and Y.
Mm-hmm.
So if it doesn't match, then we take the minimum plus one, right?
Yeah.
So we get the one,
Mm-hmm.
and then we move up, I guess. No, you just want to draw the line, or I was
I
doing
just
the
want to
numbers.
draw the line. This is the final output. See, this is
Okay,
the
this is
final
fine.
output. Yeah.
Right. So here, horizontal would be deletion, right?
Mm-hmm.
So you can
So I think we should draw the lines first, right?
from above, from above. You're drawing on the number line, I guess. You need to draw a diagonal first from 0 to 1.
0 to 1 diagonal.
Yes. Yes.
How? See, 0, 0, we have it here, right? Only if it is same, we need to do it, now.
See, we need to delete this Y and A, right?
And if you are putting diagonal, how it is deletion?
No, it's not. It's coming from the 0, 0, right? After that, it will start.
You're coming from here. 0, 0 means, or you mean here?
No, no, no. The bottom thing, the diagonal, and then it will go horizontally. This is what I meant.
Here, and then go horizontally.
Yes.
Okay. How and
A
why?
we have Y we have deleted because we jumped from Y to A. Then again horizontal ahead till R. R we are going to keep, right? R we are going to keep. Then we go to again. I think insert, go up. No, that is diagonal. We need to go up. That means we insert U. Again we go up. Insert O. Again we go up. I guess insert F and delete T. Yeah, this is the line.
If you guys don't mind, may I just play that lecture a little bit? Huh? The last part alone.
Yes.
That might be.
Yes, sir. Yeah, good. Goodbye.
So let me just share this tab alone.
We said that we have this situation where you have AI and BJ, and we don't know which one. We know that both cannot be in the sequence, because if this is matched with something, then we said that this cannot be matched with anything else because it has to be to the right of AI. So only entire suffix from I onwards. So it turns out that obviously this is a better choice. So the longest common subsequence was extended. Place you can just see this. So for instance, here again, if you look at this, so this is an E and an E, right? So then if it's an E and an E, then so why is this plus this, right? So this should be a 1. So I'll fix that. But anyway, so you can take any position and then check. So you keep computing column by column. I take the entire string bisect and the entire string secret, then I have to make 4 edits. Then this is compatible with what we know, right? You have to either delete 2 letters from both strings or equivalently delete 2 letters from bisect and insert 2 letters to make it secret. Now, how do we recover that solution? Well, as before, we can trace the path of how each entry in our table was made, right? So this 4 came as the minimum because this is an S and a B. This 4 came as the minimum of 3, 4, 5 plus 1. So we can say that this came from here. Similarly, this is an I and an S. So this 3 came as the minimum of here to here. No? Now this is an S and an S. So this must have come because it is equal to the diagonal entry. So this came from here. So in this way, we can trace down for each entry starting from the top left. The final edit distance is the value at 0, comma 0. So we can trace down all the inductive definition, and that's the yellow line. Now, when we did LCS, right, the important things for us were when the longest common subsequence was extended, and that happened in the diagonal. But here for us in the diagonal corresponds to no edits, right? That's when AI is equal to BJ, and we directly skip over to AI plus 1, BJ plus 1. So we are not interested in the diagonals, we are interested in the verticals and the horizontals. And the diagonal, yes, if it is a substitution, but in this particular example, there is no substitution, so that doesn't matter. So here, for instance, if we look at this first move, right? So this first move corresponds to a deletion, right? So deletion is when I row and j remains the same. Similarly, this one is again a deletion, right? So I'm deleting the I. Now I'm doing nothing until I come here, and at this point where I'm at this particular thing, I move right, and this corresponds to an insertion because I'm keeping j fixed, but I'm keeping I fixed, but I'm increasing j. That means I'm taking the first value in the second string and inserting it and then deleting the two together. So I'm actually inserting this R. And then in the next step, I again insert an E. Right? So by looking at the positions where changes happen, if you see why each entry was added to the
All right, guys. Hello, hello. Am I audible?
Yes.
Yeah.
Yes.
Okay, I think that clarified a little bit. Let me share my entire screen again. Now we'll go back here, right?
So you start
Huh.
top and draw the line as sir said suggested, right? So now we have to understand where did this four came from.
Hey, Mike. I have one question. All right. So if we are having bisect here and secret here, right? If we interchange these things, will the matrix change?
Yes, definitely.
Will it?
Yes, because
Hmm.
the
Yes.
SCC, see the diagonal line represents no change, which means there are common uh, alphabets.
Okay. So
Now,
let's test it out. What do you say?
I think it will become a mirror image.
All right. So I'm gonna run for this. So for secret and bisect, let me just remove the remaining things. This is for secret and bisect.
yeah, you see the twos moved up.
You want me to? Okay, go ahead. This is different.
Can you make it a bit larger?
Yeah, sure, sure. I'm just doing that. Hmm.
Yes. So now you see the twos first. The twos were in like kind of a bit lower. Now the three twos have moved up. The three diagonal
Yeah,
twos.
we can also see like it's a transpose,
Correct.
right?
Kind of. Kind of.
And yeah, this is
Yes.
secret and bisect, and this is supposed to be bisect versus secret, right?
Yes.
Right.
So from this, what we can think is that
If you can write on top.
the left will come over here, and the right, the second word will come on this. Am I right?
Correct.
So this clears us something. So the left will come
So
here,
T and I we are going to delete. So
bisect. Okay.
right.
Mhm. Fine. So just like how Sir used to say, right? And so how did we get this four? Four basically um it was, we increased from 3, so we means that means we need to go this way, right?
Right.
My Ravina, are you able to follow what I'm saying now? Ravina, Uma?
Yes, sir.
Yeah,
All right, so how will, where will it go next? How did we get this 3?
2. Next
It
is
should
2.
go to 2.
Very good. So how did we get this 2 again? Diagonally.
Diagonal,
Same again,
diagonal,
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 diagonal, again
diagonal,
diagonal.
then 1.
No, it's not diagonal.
1.
It's not diagonal.
It's to 1. 1 then 0 and
It came from 1, I think.
Yeah.
Hey,
then
wait a
0.
second. No, no, no. I think are we supposed to come in diagonal here? Okay, okay. The same thing, right? Am I making? Wait, please, someone take charge. Go ahead. From here, we have C and C common, so it came from the diagonal. Now R
Yeah.
and T, so that means it came from the bottom,
Straight down.
right? And E and T, that means it came from the bottom. And T and T, that means we can go in the diagonal, right?
Yes.
Good. So this is giving us a little bit clarity. Okay. And um,
So yeah, you can see how the diagonal has shifted from the lower half to the upper half.
that's right.
What is the relationship of the image? Is it transpose?
It's transpose.
But the
You're right.
matrix is the matrix is a transpose matrix, no?
You're right. Matrix is a transpose matrix. Right.
Means
Mhm.
double transpose cannot be there. It has to reflect the same image, is it? Once when the matrix is transposed,
The line
but that is not the case. That is not the case. So it is probably 90 degrees. It appears.
What do you
maybe
mean?
the
That's
line
not the
is
case.
also mirror image.
Huh?
I'm not able to make a relationship between the two images.
Okay. See, we have how many? Like 5, 4, and 5, 6, right? So 1, 2, 3, 4, 5, and then 5, 6, right? So next line, 3, 4, triple 3, 4, 5, 3, 4, triple 3, 4, 5. Are you following this, Subramanyam?
Yeah, that. But how did we get the first point?
How did we
First
get the
point.
first point? Means this point. Is that what you're question asking?
Oh, 4. Yeah, yeah, yeah. That one.
That is the number of
So we
operations.
so okay. So we cannot tell about.
So we have only
All
two
right.
kind of operations, right? One is delete and one is insert.
432. Correct.
No, we are three.
Then on to
Three
two
operations we
was
have.
there.
One is substitution.
But here I don't think so. We are using substitution
Actually,
No,
anyway.
no. In this case, we are not using it.
So in this substitution becomes no action. Like
please,
diagonal means no action.
do you
Keep it.
remember?
If diagonals are the same, then it is no action. If diagonals are changing, then it is substitution. If diagonals keep increasing, if our line passes through diagonal and
Mhm.
diagonals are changing, then it is a case of substitution.
Wait, we'll check that also. 1 minute.
Yeah.
We have
Your last example, yeah.
yeah, we have this 4 and tray, right?
Yes.
Hmm? Let's similarly draw the lines and see. Okay, I'll create a new paint. Have it to the background.
What I would suggest that first you manually change one word to the other.
That's what I did, right? Okay, okay, wait.
yeah. If you can fill, we will know which that number came from which one. To trace that.
Sorry, Uma, repeat. Can you please louder?
If we can fill, only then we will know, right?
Mhm.
How we
Exactly.
got that number. Yeah.
Tray and 4. Okay, you want to fill this box?
No, if you can try, then we can trace it easily.
Sure, sure,
Otherwise,
sure,
we don't
sure.
know
Sure, we'll
where
do
it
that.
came
No
from.
problem. All right. I just need to draw that box, which is going to be horrible. Right? Oh my god, this is going crazy. Ah! Please adjust with this, guys.
No issues. It's
Oh my god. Okay. Oh, now what am I supposed to write here?
Tray.
Yeah. 0, 1. 2, 3, 4, right? And again, 1, 2, 3, 4, and I'll put so for this box. Okay, the input was 4 and tray, right? 4 versus tray, right? So that means 4 comes on the left hand side, right? And tray comes on the top. Am I right?
Yeah.
Okay. So we'll do the same thing. All right. So tray here, 4 here. Works? Yeah. So, oh, come on. Who want to fill this? Subramaniam?
Uh,
The first row. R and Y. They're not same.
R and Y are different. So,
Mhm.
so one.
Good. Then it's
Then
U and Y.
R and A, R and
No, it's
no,
U and Y.
U and Y.
Uh-huh.
You're going diagonal, huh?
No, I'm going straight.
Straight up.
Straight
U
up.
and Y. Yeah, U and Y is different than it is two.
Good. Then
O and Y
mhm.
is three.
Good.
Three.
Hmm.
And T and Y is four.
Yeah.
Four.
4. Good. Okay.
Yeah. Then R and A is two.
So 2.
U and A is two. O and A is three. And T and A is four.
4. All right.
R and R is same.
R and R is same, which means we need to put 2.
Two. U and R is three.
Mm-hmm.
O and R is three.
Works. And F and R is
T
going to be
and R
4.
is four. F and R four. Yeah.
Mhm.
Then R and T is three.
Good.
U
Oh, this
and
is.
T is
Hmm.
three. O and T is four. Three.
No, how come 3?
That is F again.
Oh yeah. Okay. Okay.
It's 4 again.
Okay. Four. Yeah.
So we have the same. I think we got the same matrix like the above. Fine. So Uma, okay with this now?
Yeah, yeah.
All right. So now we look at traversing, right? Tracing back. Okay. So how did we get this 4? We got this, like, since it's not the same,
From
we
3.
came from the minimum, right?
3.
Okay. So how did we get this 3? It's
From
not
2.
here. We got it from 2. How did we get this 2? Since it's not
1.
same, we got it from
One.
1. How did we get this 1? It's not same, so we got it from 0 plus 1.
All are substitution then.
So,
Yeah.
so one more thing I wanted to tell, if you guys, I don't know if you guys remember, I mean, notice that or not. So this slanting line, it means no alterations or substitution. Sir used to tell that. Did you guys, Uma, did you notice that?
Yeah. Yeah.
No, I didn't notice. Okay, that's good.
Sir told it. All right.
Because I remember he said no alteration, no
Ah,
change, but
and he told that in this case we don't have any substitution. In this
okay,
example,
okay,
he
okay.
mentioned that
What
wording.
you're trying to tell is no additions, no deletions. Is it?
Ah, yes, exactly. No additions, no deletions.
If the diagonal elements are the same, then we have no addition or no change. If
Correct.
the
No additions
diagonal
and no
elements
deletions.
are decreasing, then we
Mhm.
have substitution.
Yeah.
Okay.
So why don't we try, like, we are almost getting the on how to do this, right?
You know what Naveen was telling, if the diagonal elements are same means all fours,
Okay.
but diagonal elements are decreasing. What does he want to tell?
Yeah. So you were saying that if the diagonal elements are decreasing, then it's a substitute. If the
When will
diagonals are,
diagonal hello?
huh?
When will diagonal elements will be the same? Because if the both I and j are same, then
Same.
only the diagonals will be same.
Correct.
Yeah,
So there is no substitution. The diagonal will change only if the I and j's are not same, and
Hmm.
the diagonal element was the least among the three.
Hmm.
That's where the substitution will happen.
That's right. That makes sense. That makes perfect sense.
That's okay.
Mhm. Right?
Right.
So I
We are
hope
doing, we are not doing deletion or insertion because the number of operations will be more, right? So that's why in this example, we are just doing the substitution for that
correct.
letter.
So earlier we were trying to do something right. So we have four and three. We were trying to R is here and R is here. Four.
Yeah, that will take a more number of operations.
Exactly.
So this is the minimum number, so we are going for substitution.
So three plus two will be there, right?
Yeah, yeah,
Or whatever. It takes more operations.
yeah.
Hmm. So this is the best way. Hope everyone is okay with this at least a little bit. Ravina,
Yeah,
you
only one doubt is Gokul. So the first one we are giving in that edit is comes to the row part, right?
correct. The first comes first. You can say like that. First comes first.
And the right hand side comes for the column part.
Correct.
Yeah, because in the exam, yeah, we should remember that.
Uma, I want to ask you guys something. All right. So we have this matrix here. Okay. So which represents I and which represent J?
The
Row
top to
represents
bottom
I.
represents row,
So can you
and
tell me what
from
is
left
the
to
point
right,
of this? Can you tell me what is this point?
1, 2, 3, 4, 4, comma,
Sorry.
four comma 4.
That's in the same page. I'm so sorry.
Yeah,
Try to answer this.
yeah, that is 2 comma 4.
Uh, you're saying that it is 2 comma 4.
Yeah,
So
I
you're
is
sorry,
saying
if
that
you
I
start
is
from
I
0,
equal to 2, J equal to 4. Is that what
It's
you're saying?
sorry, 1 second, you are
it's
starting
one comma
from 0,
three.
right? No, no, I missed as 1. It is starting from 0 index, right? I starts from 0,
Okay.
Yeah.
then it is 1 comma 3.
All right. 1 comma 3. So here I equal to 1 and J equals 3. Right?
right.
Yeah,
That's right. Fine. So okay. That's fine. So what's up? What's the next doubt? Any doubt now? Anyone want to discuss something in this?
it's clear, we can move on.
No, I want someone else to clarify this. All right. So we have the secret and bisect. I got this matrix. All right. I got this matrix and I formed this line also, orange color line also. All right. So how do I know from which one to I'm converting which one? So let's say that I want to come from top to bottom. Should I take? Is it like bisect to secret or secret to bisect? I'm having this confusion. Can someone clarify this? Hey, you got do you guys understand my doubt?
Yeah,
Uh, Shailu,
It
you're silent.
bisect to
Bisect to
secret.
secret.
Yeah, bisect to secret. And how do you tell that? That's my question here.
First two deletions, vertical lines,
So, okay, we can see that there is
then
first two
one.
deletions. So if you're coming from top to
Yeah.
bottom, then we should take the left hand side, right? So we should take the left hand side to right hand side. I think that's what is happening. Am I making sense here? Like, am I right or
Yeah.
wrong? Okay, if you're coming from top to bottom, so left to right. So whatever you have on the left, you're trying to convert it towards the right hand side, I believe.
That's how I read it.
Yeah. Uma, able to understood something?
yeah, I'm comparing with the left image, whether that's
So,
how it
okay.
is
So
happening.
we are comparing. Let's okay. That's fine. Now we'll compare it with the left image, whatever we have
Yeah,
on the
this is
left.
the familiar one, no? We will go to left and
Very good.
just
Yeah. So we'll compare it with this. So if you're coming from top to bottom, then we are going
left to right, right? That was our
uh, left to right. That
left,
means
right?
from
Yeah,
secret secret, we are
to
trying to
right.
convert it to bisect.
Yeah.
Right.
So
Okay. So let's see. So we are going right, which means insert. I think right from top to bottom. Horizontal means it's insert. You remember here we were inserting, na Uma?
once again, we are converting secret to bisect, right?
Correct.
Okay.
You were right. See, if it
Okay.
is
So okay, we are inserting B and I. Okay.
very good, yes. So we are inserting B and I, right? So
Yeah.
S we don't do anything because it's
Yeah.
the same equal, right? So there is no
Yeah.
substitution.
SCC, we don't do anything.
Yeah, same equal, don't do anything. Three don't do anything, right?
Yeah.
Yeah,
And down here.
delete,
Okay.
right?
Okay.
and again don't do anything. Pa.
Yeah.
This is really interesting and
Thanks.
confusing. All right. Any other questions? Mahi, Ravina, Shibin. Mahi, you want to say something?
Yes, sir.
Please go ahead.
So, like, uh, what you did, what's the conclusion of your doubt? I
What's the
didn't get.
conclusion of my doubt? Yeah, that's what. So we'll make a note. I mean, we'll make the note. I'll open a notepad, right? So, so what are the points to remember here? Secret, comma, bisect, right? So if you are passing it like this, right? So left will be left in matrix. First point, right? Uma, this is what we are supposed to remember, right? The
Yeah.
left word will be left in the matrix, and vice versa, right? That's the first point. So what's
Not
the
the
second?
right.
Huh? Yeah, and vice
That
versa.
one will be the right.
Yeah, vice versa. That's okay, right?
Yeah.
It also should make sense. That's the first point which we need to remember from here. Then what's the next point we need to remember? Huh? What was my doubt actually? Okay. After this, how do we convert from which one to which one? That was my doubt. Am I right?
Yeah. Left to right.
Huh?
It will convert left to right. Secret to bisect.
Okay. So left to right means or IGHT, right? Means like, for example, in this case, secret to bisect means um, top to bottom, right? Come, start from top, right?
Yeah.
End in bottom. So, all right. Mahi, were you able to understand? So if you are,
Yes.
yeah, so if you are converting secret to bisect, okay. So convert secret to bisect means left to right. So means secret to bisect means start from top, end in bottom. All right. So for this we need to put one thing. All right. So if we come from top to bottom, okay. So some points which we need to remember is the first point. Like,
Horizontal means
huh,
deletion, right? Or I forgot.
horizontal means it's
Insertion.
insertion. It's insertion,
Yeah.
right? Vertical means,
Deletion.
yeah, deletion. And usually like if diagonals
Diagonal.
are same,
No change.
No
yeah,
change.
no change. If diags are different, substitute, right?
No, not different. It should be decreasing order, in decreasing order.
Di- right? Decreases, substitute. Am I right, Ravina? Is it okay?
What is the difference between insertion and substitute?
Insert means you're inserting a new thing there. Okay, substitute means do both. Remove and remove and insert. Okay, I'll tell you.
Remove or insert an existing one, is it?
Yeah. So I'll tell you. I'll tell you. For example, see, we took this example of tray and four, right? FOUR, okay, and TRAY. Okay. So let's say we are converting four to tray. Okay, I'm going to convert four to tray. So we saw that it is going to take four. Okay, wait. Let me take it in the other page. We have the picture here, right? So four to tray. I'll just delete all these things. 4. We are converting it to tray. So we have the the order. Are you able to see this, Subramanya?
Yeah, yeah, yeah.
Yeah. So see, it's decreasing, right? So that means it's a substitution.
Yeah,
Am I
but
right?
are we using the same words? Because
Yeah, we are using the same word. See, FOUR TRAY. See this. Okay.
TRAY. Yeah, but
I need to convert this to tray. So the first
yeah,
operation is substitute, right? Able to see this?
yeah, 4 to 3.
4 to 3, it's
We are
decreasing, which
yeah,
means
we
it's a
are
substitution.
substituting what T with something else.
No,
F
substituting F with T.
F with T.
All that you need to know is it's a substitution. Okay, so that means
Okay,
F you're going to substitute with T. All right.
okay. Then we are substituting O with R.
Huh.
Okay,
We are substituting O with R. Very good. Then again,
and U with the A. Is it?
yes, and R with Y. So we got tray. You got
No, no,
this?
no. What my confusion is not that the letters in four are getting substituted at different places. You do bring a new words, new letters there, is it? So that's why I got confused.
We get those letters from here, from the input,
Yeah, yeah,
not
yeah.
from random somewhere
Yeah.
else.
Okay,
Right?
it's not the second word is not a different shuffling of the first word.
No,
The di-
no, no.
no, no, that's not okay. My thinking was that when we are substituting, the first word is getting shuffled and
No, no, no.
repositioned.
It's not that. It's not that.
That's not the way.
You're
Okay.
replacing. Substituting or replacing. We can say you're replacing the letter
Yeah,
from the other word to this word.
got it. Thank you.
Great. All right. So I think
But
it's
no, 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 no. Again, can you please go back, Gokul? Now, what way it is different from insertion?
insert. I'll take you. Okay. So we have. Okay. Let's take this example. All right.
Okay,
So since we are going to come from top to bottom. Okay. Or shall we go from
right.
bottom to top? No, let's not confuse ourselves. We'll go from top to bottom
Top,
itself.
yeah, top to bottom is better.
Okay,
Yeah,
which means bisect is converting to secret.
secret.
Okay,
Yeah,
so which means so you're coming from top to bottom. So this is what I mean. If it is straight line,
deletion.
very good. So what are I gonna delete? Delete the first letter.
B and I am deleting.
Deleting. Deleting means you're removing it.
Removing. Yeah,
Okay, so then so it's same. Two and two are
same.
same, right? So leave it, leave it, leave it. So
No
three,
change.
no change. Very good. So then you have a horizontal line, which means you have to insert something. What am I supposed to insert at this point? Insert R.
After the third letter, you have to insert.
Correct. Insert R. So here also there is from here to
What is
here.
the difference? Hold on a minute. Or we are inserting that, but in substitution, we were having the letters connected there, but in insertion, we don't have the letters connected here.
So in substitution, you will remove C and put R
Remove substitution, we remove
and
C
insert.
and okay.
Okay. Here,
In insertion, we are not removing anything, but okay, okay.
that's what the
Got it.
name itself.
So
Okay.
you are not removing anything there. You are straight away putting up a new letters.
Correct.
That's insertion. In substitution, we are removing something and putting it.
Correct.
Got it. Thank you.
Okay. So let's hurry up and finish up this code. Okay.
In the notepad,
Yep.
point number one, I think, is it correct?
All right. Secret and bisect. Left word will be left and in the matrix and vice versa.
And vice versa is something
Left word will be on top, right?
No, bro. No.
left word will be
Okay.
As per
Uh,
the example.
yeah, I'll show it. Okay. So you see this matrix. You have bisect on the left and secret on the right, and you are getting this matrix. All right. I'm gonna give the input like that.
Right?
Bisect first, secret. You're getting the same matrix. Okay. You want me to take it there? Fine.
No, the matrix we are not having diagonal scheme.
No, it's just about the points. See, we have five times four is getting repeated. Five times four is getting repeated, and five and six, right? So we write left on left. I mean, whatever the left
Yeah, yeah,
word
correct.
on the left,
Yes.
Yeah,
the right word on the right. I mean, on
yeah,
the
yeah,
top.
got it. Yeah.
Yeah, that's what you are telling that it's a transpose, is it?
Ha ha. If you do the, if you see, that's what is happening. Like we have it here, right? Secret and bisect. When I gave secret and bisect, so left goes on the left and the right goes on the right. Vikram, is it okay now? Uh, did it clear your doubt, or still am I confusing you?
I mean, as per the example, bisect is on the left, right?
Okay.
You're
Yes.
referring to the
Yes.
example
Bisect.
given by.
Bisect is on the left.
So the one on the left will be changing.
The one on the left, which means, see, from the input, in the input, okay, the one on the left will go in the matrix on the left, which means on the left means this left hand side, left margin.
Yes, right.
Okay. Left word in input will be left margin in matrix, right?
So don't you need to change the order of secret and bisect?
I'm not able to understand.
You're referring to the example given by professor, right? As per the PPT.
Correct. Here, this is what, right?
Yeah.
Okay.
So we have written secret and bisect, and the left word goes on the left.
Bro, by comes first, I mean left to right. See, you have BISECT coming first, and then you have SECRET, right? I meant this coming first. So I think you're looking at from top to bottom. I'm saying like from left to right.
Okay. Okay. Fine. Okay.
Did it make sense?
Yeah. 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 Got it.
We both were like looking at it in a different angle. That's all.
Okay. So word is like
Yeah. So if I do
written
like
left to
this,
right.
huh?
Got it. Got it.
If I put the words correctly, so left word in input will be left margin in the matrix. Does this make sense?
Yeah.
And
And you are just halfway through for right word. You just write, okay.
will be,
The top is it.
yeah, top margin in matrix. Works.
Matrix.
Right. So left to right. So converting the left word to right word. Secret, like I'm just referring to the previous one also. Secret to bisect means start from top end. Start from top and end in bottom while traversing. I'll mention that also. Is it fine, guys?
Yes.
Yeah.
Yeah,
If we come from top to bottom, horizontal line, let's say like that. Horizontal line means insertion. Vertical um, line means deletion. If diagonals are same, no change. This is okay, I think, right? This should give us an idea of this. Now we have the recording. I'll put it, upload it somewhere, and you can access it. All right, guys.
yeah, got it.
So now, shall we finish up this code? Mhm.
And you can go to matrix multiplication now.
Okay. So there is nothing here. Like I think, yeah, it's nothing here. It's a minute of work, right? The first two for loops are for nothing but the initialization of the matrix. Like so, the first for loop we saw that, and this is while it is same, and this is while it is not equal, right? While I and j are not equal.
Yeah, it
That's
is the same as whatever we did there,
yes,
no, in
yes,
the
yes,
matrix.
yes, yes.
Yeah, it's same.
Good. Okay. Hurry up. And we have matrix multiplication is associative, right? Associative, everyone knows, I think, right? A into B into C equal to like I mean AB into C or BC into A. That's fine. Find an optimal order to compute the product. This is an interesting question actually. I mean, you have some 1 marks or from in the previous one. Mm, okay, okay. So this is an interesting question. The question is, hmm, what's the minimum? Okay, I'll take this. No, I'll also take the output also. Delete it and paste it here. So what does this represent? They are giving some input. Okay, so all these inputs represent some matrices, I think, right? This is nothing. This is matrix multiplication. The topic itself is like, see, matrix multiplication. Okay, and see, okay, let's say a
Here we
matrix.
are multiplying 5 2 by 2 matrix, right?
Sorry,
No, not even 2 by 2. What we are multiplying here in the input?
I'm telling you. Give me
Five, 5 cross 2.
five matrices.
Yeah, it's not. Yeah,
It's not what?
it's
Five
not
rows.
5 2. It is 2 cross 1, 5
Once again, once again.
matrices,
So,
right?
see, so I'm what I have written is the representation. All right. So this is A, B, C, D, and E. Let's say we have five matrices. Okay,
Yeah.
you have five matrices. The A matrix is 4 comma 10. The order. This is the order of the matrix, right? So tell me, can you multiply A into B? Is it possible? Because you
Yeah.
have 10 and 10
Yes.
common, right? So which means it's possible to multiply A and B. Am I right, guys?
Yes.
Okay.
Yes.
No, sir. How?
How do you multiply matrix? So we have a matrix 2 cross 3. Okay, we have another matrix which is 3 cross 2. Okay, only if these two are compatible, the rows of the first matrix equal to the columns of the second matrix, then only you can multiply it, right?
Sir, these are not the numbers in the matrix. These are orders of the
Exactly,
matrix.
that's what I'm saying. That is what I'm saying. Orders of the matrix,
Okay.
So
number of
row and
rows,
column.
number of columns. Ravina, did you understand?
Yes, sir.
So this is not the values in the matrix,
No,
it's
this
the
is
number of rows in
not
the
the values in the matrix. These are representations of order of the matrix.
order of matrix. Okay.
Okay, and if you're given such matrices, okay, mm,
So the question is,
mhm,
which combination of matrices, if we choose first
correct,
or later,
mhm,
that we will have to do the least number of multiplications
multiplications.
or computations.
That's right,
That is the question. That is the
ah,
idea of this code.
correct.
I think it's AB.
Sorry,
So if you do AB, we'll have like that many computations.
Yeah, that's a
It will become 4 cross 3, right? AB.
AB is 4 cross 10. Okay, sorry, AB
But when
matrix
you
is going to be
multiply,
sorry,
it
AB
will become
matrix is
4
going to
cross
be 4
3.
cross 10. 3, right? You're right. Come on.
Yeah. So in that way, we have to calculate, and
Hmm.
the final should bring the final as a least multiplication.
Hmm. Yeah.
that's the answer.
No, no, I'm just talking about A and B. You have to calculate
This is
further.
talking about AB, right?
So matrix multiplication is associative. So for example, if we choose AB, the number of multiplications we'll have to do is 4 into 10 into 3. That is 120 just for the first two. And then we'll get a matrix which is 4 into 3. Now the answer of AB is 4 into 3. Now we do it with C. So
Hmm.
C is 3 into 12. Now for this, we'll have to do 4 into 3, that is 12 into 12, 144.
AB into C, the number of operations
Now we
is
are done with ABC. And the output we have is 4 into 12. I
yeah.
mean, the order of the uh, answer.
Hmm.
In total number we have done 144 plus 120.
Yeah. That's okay.
And now,
We'll have that separately. Yeah.
yeah, so now we have an output which is 4 into 12. So
Now
after
this
doing
is since this is common. Yeah,
ABC,
4 into 12.
12, 4 into 12.
Okay.
So 4 into 12 is compatible with D
Yep.
because D is 12 by 20.
Hmm.
So the number of computations we'll again have to do is 4 into 12, which is the common row and column, into 20.
Hmm.
So 4 into 12 is 48 into 29, 60.
Yeah.
And
This will give us
the
A, B,
output
C,
matrix
D.
is 4 into 20.
Yeah. Right. So this is 960.
So on the extreme left, we have the number of computations up till now. Now the last that we are doing is 4 into 20 and 20 into 7.
Hmm.
So the total number of computations would be 4 into 20, 80, 80 into 7, 560. So obviously, this is now much higher than 1344. So obviously, there is some other way which if we have, say for example, 4 into 10, what else can we do first? Maybe we can do B and C first.
Let's not take directly here. Like sir would have explained this in a very simpler example, right?
Right.
I mean, probably you would have taken three matrices and then given the answer. That will clear everyone else easily, right? Okay, here we are. I'll go to the end of the slide. Yeah, Vikram. This is an interesting example.
Yes. So we need to find
We have
which
three matrices.
combination we need to choose first. I mean, as we saw in the previous example, A, B, C, D, E, by
Mhm.
just doing A into B into C into D, we are going, the computations are increasing. So in this example, A is 1 into 100, 100 into 1. So if we do AB,
Mhm.
it will be 1 into 100.
1 into 100 into 1, right? Which is 100 computations for AB,
Yes,
right? And the matrix will be 1 cross 1.
1 plus 1, correct.
Mhm. Yeah, so
And
this is
next
1
one
cross
will
1 and it is into 1 cross 100. So 1 into 1 into 100. Okay? So 100
right.
steps. So if you do it in AB, then multiplied by C, it takes just 200 steps, right?
Yes,
But if you do BC, which is like, this already is taking 10,000 steps, right?
yes. So the code helps us to find the least, I mean, the combination which gives the output with the least number of computation. That's the idea of the code.
Yeah. So Uma, Ravina, Mahi,
Yeah.
Subramanyam.
Yeah, yeah. Following it up.
Yeah. Ravina and Mahi, any particular questions as such?
It's clear, sir.
Good. Okay. Go ahead, Vikram. You want to continue? Like, okay, that's all. That's all right. Nothing else is to be discussed over there.
Yeah.
So we shall try to look into the code. What do you say?
Yes.
Good. Mhm. Here we are. Uh, this looks like an easy one. But earlier, okay, wait a minute. Is this the correct one? Okay, what's this? Okay, they have two different implementations for the same. So this is like using for loops. This is normal one, and they have an inductive structure. So which one should we try to look into?
Go down. Is the inductive structure is giving time complexity different? Huh?
Inductive structure. We go of n cube. N cube same.
Oh, why do we go for inductive structure?
Mm-hmm.
No, why do we go for inductive structure then?
I'm not sure though.
Compare the output, is it are the same?
Output is also going to be the same. See, at the end, the output should be the same, right? So here they are given a different test case, and there they have given a different test case,
Yeah,
right? Probably the speed of computation is different. Complexity is okay, but the speed, there is a difference in speed and complexity, right?
yeah.
Maybe the number of operations involved. Hmm?
Okay.
But it's ideal to look into both. Let's first check into the inductive structure, right? So uh, we are passing all these things, right? So five matrices, shape of five matrices are given, and n is the number of length of the list, right? And C is an empty list for I in range of 5 in this case, right? And L is a 0, and wow. So what's happening here? Okay, let me just take it so that we can do some visualization and see. Where is the code? right? So after this, may I print C and show you? That should give you the answer, right? Basically, we get an input like this. I mean, so we get C is like this. Guys, hello? Hello, hello. A C is a matrix. We are trying to compute, like, just like how this is an index structure, right? So we are trying to, you know, construct a matrix like this, just like how we used to do always. Uma, okay?
Yeah, but depending how we got that number and then 3, 4, 5.
How
Okay.
we?
No, that J, that number of columns, no, 5 we are getting.
Yeah.
How do we got that?
How did we get phi as n? Is that what your question is?
Yeah, that we got it from here, right?
Correct.
From A.
Hmm.
Okay, let's go ahead. As of
Yeah.
now, no.
Yeah. As of
Nobody
now,
knows.
this much is done. Okay. Even I still didn't go further. Okay. So for different in range of, so this is gonna start from 1, 2, 3, 4. Okay, 4 iterations are gonna happen. Please. Right? Here, how many iterations are gonna happen? Zero. Oh, this is fine. So what will be the values of I?
Calculate. Yeah, each step we have to calculate. No?
Yeah, it's gonna change every time, right?
Yeah.
Okay,
Initially,
but still we'll write the right what and all is gonna have come. Right.
yeah.
First iteration it's gonna be zero, comma
And 5 minus 1, 4, right? 5 minus
n minus
4,
difference is going to be diff is one, right? First one. 0 to 5 minus 1, which is 4. Is that what it
yeah.
okay. So this is the first iteration, right? So what will be the second iteration? We'll start from 0 and 1, 2. I think it's that's all right. Here in this case, the first time that's what is happening. See, 5 minus the difference. For second iteration, difference will be 2, right? So n is 5, 5 minus 2, which is 3. So that is what is happening, 0 to 3. Okay. Did you guys, Oman, were you able to follow this?
No, I'm just thinking.
So,
Okay.
but there will be one more, no? Like zero, one, zero should be there.
Repeat.
One more iteration should be there, no?
Where?
After zero, one, there should be one more, I guess.
That's the, yeah, you're right. There's one more, which is 0,
Yes, sir.
where I is 0. Uma, were you able to understand what is happening here?
Yeah, yeah. I'm just calculating. Yeah.
This, how many iterations, like every, so this is the first iteration for, this part. So we have 4 iterations. The inner iterations, what and how many iterations is going to happen, that's what we were computing actually.
Yeah, it depends on I. Yeah.
Yeah, it depends on I, that's right. Okay. So J, let's come to the first iteration, first iteration, like the outer first iteration and inner first iteration. So 1 comma 0, right? So diff is 1, I is 0, so J will take the value of 0, 0 plus 1.
1.
Yeah. So which is 1. Okay. So J equal to 1, KL is equal to an empty list. So what is this? KL dot append IK dim of, my god.
You have to write that I value and J value there in the for loop.
Okay.
In the for loop, in the right hand side, you can write I.
The values basically. You want me to print it up?
No, no. Just write it down so that we will know what is K, right?
Okay.
Yeah.
Right.
I is 1, right? Sorry, 0.
Yeah, in this case 0, you're right.
And J will be 1.
Hmm. 1.
Now K will be 0.
Okay. 0 to 1. So it's top 0 iteration. Yeah, you're right. K will be 0. Okay.
So it is 0, comma 0.
Mm-hmm. C of 0 comma 0, which is 0, right? And
Yeah.
then this is 1 comma J is 1. So 1
1, comma
comma 1. here, uh, plus dimension of, what is this dim, what is this dim, whatever we gave here, we gave the input,
Yeah,
that's the dim of I is 0 0 0
zeroth element, 4. It will be 4.
4 and 0 1, 4 into 10 into, okay, this one, I mean j is
Okay.
1, no? So 4 10 3, they are multiplying this,
Okay.
they are multiplying these two matrices, the number of steps, this, okay, this is actually calculating the number of steps included. Okay, this is making sense, this is making sense. I think I'll go here. I think sir will give a, yeah. Does he have a practical example here? Oh my god, he doesn't have it here. But I think we are moving forward somewhere, right? Okay, go ahead. So at this point, after this for loop, uh, shall we print kale? Okay, kale, minimum of kale. Okay, kale. Okay, right. Okay. So what is happening is basically we are taking the first one and trying all the possible combinations. I think when you're doing, when you keep AB as a common thing, okay, and then multiply the rest of the things. If you guys remember, this is what we got. 120 we got, right, Uma?
Yeah. Yeah, yeah. We got it.
Okay.
360 also? No, right?
Yeah. How did we get this three? Did we get the 360?
No, we got a 4.
No. How did we? How did they get the 360 here?
Um,
Um. Yeah, it's here. See, they are multiplying these two.
okay, 120 into 3.
Yeah, 120 into 3 is 360, right? So I think this is
A,
what,
B, B, C, A.
24. Yeah, this is yeah, that's right. So first line is AB,
A,
second
B,
is BC, then CD, and
C,
then
D.
DA,
Yeah.
right? So that is what is happening here. Okay, so
Still,
840.
I'm not able to get it. What is this comma is coming?
Sorry.
No, this 840 comma 264.
Yeah, 840 comma 260. So that is coming in the, see, this happened in the first iteration. Wait, I'll print I also so that we'll see what I is. Okay, so no, so I should not print I. I think I should print diff. See, so when the diff is one, so they are multiplying A, B, B, C, C, A, right? Okay, so during this, we are in the second iteration. Okay,
Okay.
second iteration means how much did we get for this?
840 comma 264.
No, no, for this is like 120, I think, right? So we
Yeah,
got 120
120.
for this plus how much did we get? I mean, how much will we get if we multiply?
120 into 3 comma 12 is that?
Hmm?
But sir, here we are choosing the minimum winner from all these two combinations.
That's correct. So at the end, they are taking the minimum, right? Which is one.
No, no, not at the end. Like after multiplying two matrices, they are checking a minimum from 120, 360s, and 720 and this, I guess.
Okay. Oh, okay. So,
And then we have to proceed for three matrices, combination of three matrices, I guess.
acha,
Like two
okay.
we did, then three, then four.
Hmm. Yeah, that seems right. So, Uma, did you understand? Like, what she told
No,
is
no.
that we are multiplying A, B, B, C, C, D, and D, A again. All right. And then
Yeah.
of the all, you are gonna take the one with the minimum multiplication. So which
Yeah.
is this. All right. So now this matrix is gonna converted into, you know, 4 cross
Single
3,
number.
right?
Yeah.
It's 4 cross 3. Okay, okay. Now you see, uh, multiply. I think what's going to happen here. How did we get that 840? Is it somewhat related here? 120.
So,
Yeah.
so do one step back, like all the four matrices, please.
Mhm. Go ahead.
Yes, yes, now proceed.
I thought like if you ask me, usually what I do is I would print uh, all these things, whatever we have here. Like if I want to debug some code, okay. So in this case, we'll know what is what. So so ik is I think it's fine. So I think in this case we need to print ik also. Okay, comma j also we shall print. Okay, but these are basically the dimensions. So 4, 10, 3, right? And then 10, 3, 12. See, 10, 3, 12. Basically what they are multiplying, and it comes out to be 120 here. Blah 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 blah. Mm,
See, this is
yeah.
like easily the toughest. This is like the toughest code, to comprehend. So it's very important to understand the slides
Okay.
where you can see that when you multiply A to B and B to C,
Hmm.
necessarily you can do C to B. That is the main catch. So we need to understand all these slides. I think this is like it might take at least half an hour
Okay.
because this is easily the toughest code. Even I haven't understood it completely.
Okay, probably we should. Now it's already time. Now I don't think we'll be able to finish this up. But you guys can, I mean, look into it, and we'll.
So we can do it like this now, like what I saw from the code. Like first we have to make the pairs of the matrices. So first we will take the two pairs of each matrices and we will see the least one and we will pick the least one pair. Then we will compare it again from the single matrices and then we will make it three pairs, then four pairs, then five pairs. Like this way we can get the minimum complexity.
I think whatever you're saying, it seems to make sense actually. What I'm also thinking
See,
about.
this is like combination. This is not like a permutation or combination. This is a combination, but you only combine the matrices moving ahead. Like, I mean, how can I say, the list that is given? We can only take combinations forward. Like that's why that slide shows that ing. Like for example,
I'm
410,
speaking about
right?
forward learning.
Yes. So if once we understand these 4 or 5 slides, then the code will be much easier.
Hmm.
Otherwise, it's quite tough to comprehend.
So probably we'll come back again and look into this the next session. Okay. By then there'll be some live sessions also, right, which we can refer to.
No, live session they have not discussed this matrix multiplication.
But we'll discuss Uma the next session.
Yeah, yeah.
Sure. Sure.
Yeah, yeah, I'll try in the YouTube. You'll get it very easy in layman terms.
Right. So see,
Most of the things
this is
from
very
lectures are
important.
very complicated.
Sorry.
This grid shows how they have calculated it. This particular grid, this is how it is done. Now we
Okay.
have to, yeah,
Understand this, I think. Yeah,
yes, because the earlier concepts we were doing the same way, right?
yeah.
Once we understand this, then we easily understand the code.
Hmm. We should try to understand this also, right?
No, only this I think. This is giving the answer now, Gokul. Maybe if we understand these tables, it will be we are
Okay.
done.
So let's see. Okay, here 1344 value is representing the minimum number of the multiplication steps. We can identify the order of the multiplication of the matrices by sorting the k value.
No,
Um,
no, we should not fill the table. Only then we will understand, right?
that's right.
I think it's better we everybody goes through this, once,
Yeah.
then we discuss it. By the way, what is the syllabus for quiz
Yeah,
2?
and look at this. They have even given us the order, not just that. See which order we have to multiply. So we need to understand this, and this is a really good, interesting thing to understand, right?
Okay, we'll go through it. Yeah.
Maybe we'll come prepared next time, right? So, and the syllabus is going to be like 8 weeks.
Yeah, 1 to 8.
Okay, so this is
We are
9.
already ahead, but we'll stop from this week. All right. So, and we'll start
So when
preparing.
will be the next session?
Actually, for the next 3 days, I'm out of town, so I won't have my laptop also. So, I'll ask Srivinay to join. All right, he is really interested to take. Like, hey, does he take the other session also? I don't
No,
know.
sir, we don't like that mentor. That mentor asks questions from us. I don't like him.
So what do you think I do? I also always ask the questions to you guys.
Live coding, he takes sessions.
So he takes live coding, which is on Saturdays, huh?
Yes,
No, programming assignments, no? I saw him in the programming assignments.
How many sessions do you have usually?
And
3.
now it is, they are randomly giving so many sessions. Programming assignments also it become a session now.
Mhm. Okay.
Yes, right.
So ideally, I mean, see, till Sunday I'm not available. That's the problem here, right? So, but after Sunday, I mean Sunday on Sunday I'll be available. In the next 3 days we don't have any session. Okay, Sunday evening we'll still have a session, but we'll start with the previous term question papers. No, no, let's do
And
something.
nobody will come on Sunday. We will be waiting.
What?